This is a printed circuit board for making a clone of a Big Muff style overdrive pedal. Now, you can only buy the circuit board, you can't buy it as a kit, and you have to source your own components. And I looked at the parts list, and some of the components I definitely didn't have. I didn't have any of these types of capacitors, so I bought some. Everything else for the build, I'm hoping to source from bits I got lying around. It needs some NPN transistors, and the type it specifies I don't have, but I got some of these BC547s, which I believe are found in electroharmonics pedals. So I'm hoping they will be a suitable equivalent. The other parts that you need are diodes and resistors. Well, there's a box of resistors. I've got a little tub here, and inside this tub there's 4 diodes. There you go, 4 diodes there. I don't know if they're the same value or not, but they look about right, so I'm going to bung them in. I'm literally just going to, it's going to be like making a cake when you don't have all the right ingredients. And I'm just going to chuck it together with whatever parts I've got. And if it doesn't work, I'll go, all right, it's a fair cop, and I'll toss it in the bin. And maybe I'll build another one day. If it does work, then I should probably mount it in a little tin box, something like that. And I will have another homemade pedal to add to the ever-growing collection of homemade effects pedals. I'm going to get on with this and start building. With any build like this, simple thing to do is to do a printout of all the parts that you're going to use, and then cross out each part each time you install it, and then you know what you've got left to do and what value that you need. Okay, the 4 diodes are in place now, and they're really the heart of any kind of overdrive pedal, because it's pushing the signal through a set of diodes that gives it the clipping, that gives it the sound. Next thing I'm going to do is I'm going to put in all the resistors. I'm working on this in the same principle that I do any project build, where you put the smallest components in first, like the diodes, and then the components that stick out more, that are higher up, they then go in afterwards. Okay, it's been an interesting couple of hours. It's actually nearly midnight, so it's getting on a bit. Now, there was a couple of resistors I didn't have the right values for. There were some 82Ks, and I put in 81Ks in, but that's still within, you know, a percent spec. And here, these resistors here, it required some 390K resistors, and I doubled up and I made some that came out to 387K, so they're close enough. If this does cause a problem, then I'll order the right values and put them in, and I might well replace these anyway, because, you know, it does look a bit ugly, to say the least. I put some sleeving over that one because I didn't want it touching the other one. I mean, they shouldn't touch, they shouldn't move, but just to be safe. But other than that, all the resistors are now in. The next thing to do, I guess, will be to put in the transistors and then the capacitors. Again, I haven't got all the capacitors required, although I've got some of them, and I'm hoping I can use some other types of capacitors to the same value to do the others. What ones have I got here? These are, those are 100 nanofarad. So they're 100 nanofarad capacitors. And these are 47 nanofarad capacitors, so that's a fair chunk of them. I need some 560 picofarads and a 3.9 nanofarad, I should say, and some 10 nanofarads. So I should have those in other types. So I'll whack them all together anyway and see what we come up with. Right, it's half midnight. I've nearly completely populated the board. I drew a loss at 560 picofarad capacitors, and this big thing here, that's in the slot of a 3.9 nanofarad, and that's actually a 4.1 nanofarad. So I'm going to order or try and get hold of some replacement capacitors, some 560 picofarads, because I need 3 of those. And I might see if I can get a replacement for that as well, just because it makes it look better. But other than that, I think this is pretty much complete. Okay, it's now 1:30 in the morning, and this may look a bit crude, and I agree it probably is, but that is a fuzz box that has been built out of leftover bits and bobs, and in essence it works. It's giving me gain, it's giving me a tone control. What it's not doing is giving me full-on heavy overdriven fuzz. Now I don't know if it's because that capacitor there is too big, because that's the real odd part out, and I think I'm going to change that capacitor to one that's physically smaller and a lower value. And once I've done that, I'm going to try it out again in the morning. So that's it for the moment. A few days have passed, and here is the finished board. Now, I made a few mistakes. The first thing is I had the wrong diodes, which I think I've already mentioned. So I changed the diodes, and it sort of worked, but it didn't really sound right, and I wasn't sure why. And it turns out, well, it could be one of two things, but certainly one of the main things was I changed the transistors to the actual transistors that they wanted specified. The correct transistors are 2N5088, which these four are. Now, if you're wondering why they're sticking up a bit, it's because, as I said, after I put the new diodes in, it still wasn't working properly, and I thought if this thing is just never going to work, then I can at least reuse the transistors. However, what actually happened was this resistor here turned out to be broken. It had a crack in the middle. Now, whether that was when I was hoiking out the old transistor or hoiking out the diode and I just crunched it with a pair of pliers by accident, I don't know. But anyway, that resistor was dead. And once I replaced it, everything came good. So what I'm going to do is I'm going to now show you how this thing works. So I finished the pedal and it's all on the bench. I'm running it off an external power supply. Has got a battery connector as well. I'm going to turn it off. I don't know if you can see it, turn it on and off there. I don't know if you can see the little red LED light up. The way I wire the foot switch is a 3-pole double throw switch. Here we've got the external power connector, and this effectively is a switch. The ground is common, and the plus rail is then switched through. You have the battery terminal coming in, that goes through the switch and would then feed the circuit, and when the power's plugged in, it then switches out the battery and switches in the power, and that's basically how it all works. So this is our clean sound. I'm playing my Gretsch Streamliner. I've just got a little bit of reverb on the amp, but otherwise you're hearing it directly through an SM58 into the camera. So I'm going to switch the pedal on. I'm going to turn the drive down. I've got level control here, which can get pretty loud. Tone control here. I'll leave the tone in the middle with a little bit of drive. As I turn the treble up, and as we bring the drive level up a bit more, this is full drive. Turn the level down a bit. You can hear the guitar is actually feeding back because I'm playing a hollow body. So yes, great lead tone. Okay, I don't actually have my personal clip microphone, so I'm just using my Sontronic Solo vocal microphone. Very good vocal microphones. If you ever thought about using something different to an SM58, I really recommend these. They're built like tanks. They've got really good dynamics on them, very sensitive, and I think they're just a great vocal mic. Not that I've been able to gig with it much since I bought it, because I bought it, well, just before that thing happened. Anyway, on my Black & Decker Workmate, you will see some bits of electronics, hopefully, and I'm just going to play this going through my Marshall JTM 45 into a 4x12, and it's mic'd up with an SM58, and I'm just recording this straight into the computer. So this is the sort of clean sound that I'm using, just to get some sort of balance. And I've not got any other effects in the chain at all. I've just got the two inputs linked. So I've got a little bit of top end and a little bit of full sound on it. And I'm just going to now switch on the pedal. So this is with most of the drive turned down, the EQ roughly in the middle, and I've set the gain, the overall master level, to be similar to how the clean sound was. So this is sort of basic drive. So that's a fairly chunky sound. I'm just going to lift up the gain a bit more. And then if I crank it right up, so now I'm going to whack up the treble a bit. I've got my big muff plugged in now. I am using a power supply. That might be because it's a bit close to the box, or it might be picking up a bit of hum, but this is in essence the sort of middle settings of original Big Muff Pi. Then if I switch on the circuit, so that's the pedal. And that's the Big Muff. So I think just from that little test, I'll just swap them over one more time. So this is the original Big Muff PI. And this is the circuit. So yeah, from those two comparisons, I think it's fair to say that this £1.99 PCB with a bunch of components on it is very, very close, if not pretty much spot on, to the sound of the original classic big muff pedal that we all know and love. As I look into my garden on this lovely day, it's looking quite nice, and hopefully the sun will be back out later on. Anyway, back to the build. Now, this pedal design, I wanted to be a homage to my beloved GP Electronics of Buffy Tracy. So I've got these kind of old school knobs that are very much like the ones that you'd have seen on one of those amps. If you don't know what I'm talking about, I've got a couple of videos on my YouTube about GP Electronics amplifiers. I'll put a link in the description. However, it's where to put the battery, because if the battery's at the bottom, it means the foot switch is going to be around here, which is quite close to where the pots are. Because I wanted to keep them in this this layout, I think I'm going to have the battery actually mounted in the middle, and then the pot can go at the bottom, and then everything else can tuck in the side. The only thing I worry about is where the jacks are going to go, so I might move the jack, actually have the jacks lower down rather than at the side that you would normally find them. And actually, if they're offset, it means when they're in a pedal board, you've got one jack there and the jack of the next pedal will be here, so you can actually fit more into your pedal board, so it's a good little space saver. So I think that's what I'm going to do on this one. Here it is, here's the finished pedal. It's in a nice solid die cast box. One thing I did do is I've grounded the case, which you should always do, or else you're going to get hums and buzzes and things. But there's our three controls: our drive control, our gain master level control, and our tone control. Nice little, nice little red LED there. I did make a mistake with the power connector. I put it there originally, and I should have really had it offset, because this area here of the case is where the circuit board is inside. How I mounted the circuit board is I just stuck some gaffer tape on the back of it and lined the back of the case with gaffer tape, and then that way there'll be no shorts, and it just sort of fits in there and just sort of dangles. It's not ideal, but there's, you know, it's quite tightly packed inside, so it all works. Anyway. And that's it. Well, job's all done. So I really recommend this as a build if you fancy knocking up your first effects pedal. Maybe not your first, but certainly once you've got used to soldering and measuring values of components and things, it's a very easy build. The instructions are very clear, and you know, for a few pounds you could have yourself a really great pedal. So thanks for watching. If you've enjoyed this video, please like and subscribe, and click the little bell icon as well, because there'll be more videos coming along in the not too distant future.